Meet cami. Cami is a Rocky River crayfish. Crayfish like cami are native to the rivers in North Carolina's Piedmont region. But it's what cami is doing that's important here. She's attacking and devouring what looks like a piece of cake. It's actually called organobait, and there's a lot of science baked into it.
This is bait, strategically designed not from a researcher's viewpoint, but designed from the fishing industry's viewpoint.
And here's why researchers believe cami's favorite cake could help save an industry and the ocean. It's all about forage fish. They're also known as small schooling fish. Forage fish are those oily fish we know of as sardines, mackerel, herring, and menhaden. And forage fish are important to all sorts of industries. In fact, 40% of the fish that are captured around the world are forage fish. That works out to about 35 million tons per year. Forage fish are used for fish feed for aquaculture. They're also used as a feed source for barnyard animals. Forage fish are also used in pet food and for human consumption, including vitamins and fish oils. Finally, forage fish are used as bait fish for crabs and crustaceans. In fact, almost half of the forage fish caught are used as bait. That huge demand for forage fish is leading to overfishing, and that shortage threatens the crab and crustacean fishing industry. Bait prices are rising, and in some cases, bait is simply not available. But the overfishing of forage fish also threatens the entire ocean. That's because forage fish form the base of the ocean food chain.
These fish are exponentially important to the ocean. Forage fish transfer energy to all the fish in the ocean. So all the larger fish rely on these fish. All the seabirds rely on these fish.
And that's where cami and that cake come in. Cami was the first test subject for a synthetic bait made by Kepley Biosystems. Scientists at the small Greensboro startup discovered the molecules those small bait fish emit that attract crustaceans, and they put the molecules into the cake.
And we took all of those molecules and then teased out which ones were those that were necessary for attraction. And then we encapsulated them into a predominantly calcium-based matrix that we can tune to specific release rates that can be deployed, slowly release the attractants in a synthetic form, not using a forage fish, create a scientifically sound solution that's environmentally good.
The cakes are made in the lab and baked in standard cooking ware for testing in the field. Those tests are conducted all along the coast in a variety of fisheries.
We have formulations for all different areas, all different ecosystems that will attract the different species. Those ecosystems have numerous variables: salinity, temperature, time, tide, all of those factors come into play. So designing the matrix was a real challenge. So they wanted something that would not spoil, that didn't have robust storage requirements, and something that can be tailor-made and tuned to the specific individual needs. Whether it's in Florida, where a fish is sitting out there in a bait chamber for 15 days, or in Nova Scotia, where it's sitting out there for a day. We want it to completely release during that soak time all the molecules, optimally attract all the crustaceans in the area, but not such that it releases them all immediately.
Kepley Biosystems is a small startup affiliated with the Joint School of Nanoscience and Nanoengineering in the Gateway University Research Park in Greensboro. It's a partnership between the University of North Carolina, Greensboro and North Carolina A&T State University.
So if we can make a dent in the amount of forage fish that are being taken out of the ocean just to bait traps, we will be making a difference. There's just no doubt about it. But not only ecosystem saving, but also financially for the fishermen, because we can outcompete what forage fish prices are right now. And of course, you got the whole storage. Fishermen won't have to store it. You can store it in your boat without refrigeration. It's convenient. It's not rotting fish in a bucket. The problem that fishermen encounter, we solve all those problems. And when it's fully adapted, we think that we can make a huge dent in the amount of forage fish that people are taking out of the oceans.